All right, let's just dive right into this explainer. We're going to pull back the curtain on the transmission system. Now, we all know engines generate this massive, almost explosive power, right? But taking that raw, chaotic energy and translating it into smooth, synchronized motion at the wheels, well, that is an absolute masterpiece of heavy metal and physics. So today, we're going to break this entire system down piece by literal piece, so you can see exactly how the power from your engine actually makes it down to the pavement.
To really grasp this journey, here's our roadmap. We'll look at what a transmission system actually is, how it generates and stores power, the clutch as power's gatekeeper, the gearbox for controlling speed, how power actually gets delivered to the wheels, and finally, how to keep the whole system running smoothly.
Starting off with Section 1, what is a transmission system? The path from engine to wheels.
So here's the absolutely crucial thing to remember. An engine on its own just isn't enough. I mean, you could literally have the most powerful engine in the world, burning fuel, creating insane amounts of energy, but without a transmission system, your car isn't moving a single inch. We need a dedicated physical network to carry, control, and direct all that raw power straight to the wheels where it can actually do some work.
Now, this visual right here brilliantly illustrates our complete roadmap. We're starting way over on the far left, right at the engine, and we're going to travel all the way to the rear wheels on the right. Just think of this as the highway that energy travels on. It's not some straight, simple pipe. It's actually a dynamic assembly line of highly specialized components constantly passing the baton.
And specifically, there are 8 distinct stops on this journey of power. These are our messengers and gatekeepers: the flywheel, the clutch, the transmission gearbox, the propeller shaft, the universal joint, the differential gearbox, the rear axle, and finally, the wheel itself, the whole shebang.
Moving on to Section 2, generating and storing power, where the journey begins.
Over on the left, we've got the engine. This is the heart of the beast, right? It converts the heat energy from burning fuel into pure mechanical energy. But here's the catch. An engine's power delivery can actually be pretty jerky because of all those internal combustions, and that is exactly where the flywheel comes in. Think of the flywheel as a heavy, spinning energy storage bank. Its one job is to capture the engine's power and hold on to it, using its own momentum to smooth out the power delivery so the rest of your car doesn't, literally shake itself to pieces.
Section 3, the clutch. Power's gatekeeper, bridging the gap.
Notice how the clutch physically sits right between the flywheel and the gearbox. It is the literal bridge between the two. You can kind of think of it as the bouncer of our mechanical club. Its entire purpose is to seamlessly connect or completely disconnect the engine's power from the rest of the driveline. When it's engaged, boom, the power flows. When it's disengaged, the engine can just keep on spinning happily, but the rest of the transmission system sits safely idle.
So you might be wondering, how does this mechanical gatekeeper actually translate to your physical experience sitting in the driver's seat? Like, why do we even need the ability to randomly interrupt the flow of power in the first place?
Well, it all comes down to control. Whether you're driving a manual where you push the pedal yourself or an automatic that does all the heavy lifting for you, the clutch is activated during 3 critical actions: whenever you brake to a stop, whenever you shift to a different gear, or when you're first starting the car. During all of these, you're manually telling this gatekeeper to temporarily halt the journey of power. Because if you didn't, the rigid connection between the stopped wheels and that fast-spinning engine would cause the whole thing to violently stall.
On to Section 4, the gearbox. Controlling the speed, the brains of the operation.
Okay, so once the clutch graciously lets the power through, it enters the real brains of the operation, the gearbox. The gearbox's entire job is to adapt the engine's raw uniform speed and strength to whatever you, the driver, immediately need. Let's say you need massive pulling power to climb a really steep hill from a dead stop. Or maybe you need high-speed cruising on the highway with almost no pulling resistance. The gearbox is what makes one single engine capable of doing both of those very different things. And it does this using interlocking gears that physically change ratios by sliding different size gears into place, like going from big gears that give you high torque and low speed down to smaller gears that offer high speed but low torque. The gearbox is mathematically transforming the engine's output. It adapts to power to perfectly match your immediate driving conditions. It's honestly a real game changer.
Section 5, delivering power to wheels, the final stretch of the journey.
So the power has been adapted. Now notice the propeller shaft, also called the drive shaft. It takes all that perfectly adapted power from the gearbox and sends it all the way to the back of the car. But cars hit bumps, right? The suspension is always bouncing up and down. To stop this solid metal shaft from just snapping in half, it uses universal joints, or U-joints, on either end. You can picture these like the wrist on your arm. They allow the power to keep flowing flawlessly, even while the shaft itself is flexing up and down at an angle. But eventually, that spinning shaft hits a major physical hurdle right at the back axle.
And that hurdle? It's cornering. See, when a car turns, the outside wheel travels a slightly longer distance than the inside wheel, which means it literally has to spin faster. If the rear wheels were just locked together on a single solid axle, the tires would violently skip and drag through every single turn. Enter the differential. This beautiful arrangement of gears is an absolute cornering genius. It takes the power coming straight down the car, turns it 90 degrees to the axles, and then cleverly splits it. This allows the outside wheel to seamlessly spin faster than the inside wheel during a turn. Problem solved.
And finally, Section 6, keeping your system running. Essential maintenance for longevity. Now, of course, absolutely none of this incredible, high-stress engineering matters if we don't take care of it. For the first half of our journey, maintenance is all about secure connections and good lubrication. That means tightening those flywheel bolts, checking and replacing damaged clutch cylinders or plates, changing your gearbox oil strictly by the manufacturer's schedule, and definitely swapping out a bent propeller shaft if the vehicle happens to take a hit. Moving to the back half, those hard-working universal joints, they need fresh grease after servicing. And if they start making a clunky noise, well, they're done, you gotta replace them. You also want to keep that brilliant differential bathed in fresh oil so the gears don't just grind themselves to dust. And finally, keep an eye on your rear axles and wheels for physical wear, replacing them whenever the splines get damaged or the treads start giving out. Going through all of this, it really leaves you marveling at the sheer brilliance of the engineering happening right underneath your feet every single time you go for a drive. So the next time you effortlessly take a sharp turn to go grab a coffee, I want you to think about this question. Without the pure ingenuity of the differential gear, how would your car ever take a simple corner? The answer is, it wouldn't. It would just skid and drag. It is truly a masterpiece of mechanical cooperation. Keep questioning how the mechanical world around you actually works, and I'll catch you in the next explainer.